So yeah, I would like to give a short overview on how Sedak went a small step for architecture and one giant leap for glass by introducing our new product, which is actually Sedak Tempered Plus, so glass without anisotropies. So when we are talking about glass and glass facades, they are mainly praised for the elegance, homogeneity, and also the visual aspect, like you can see here on the image. Now imagine this glass facade with disturbed optical homogeneity. So this is the architect's nightmare. So we can call it by its name, actually anisotropies in glass. We have it in tempered glass. Raw flat glass itself is fully isotropic and homogeneous, but when it comes to tempering, these anisotropy patterns can occur as rainbow colors, white or dark spots on the glass when having a look at several angles. According to the standard, the isotropy itself is a strain pattern that may become visible under certain lighting and other conditions. Furthermore, it is described as a characteristic and should not be taken as a defect. So according to the standard, technically, it's not a defect. However, the architects don't like it. And the origin of anisotropies can be found in the tempering of the glass. So both fully tempered and heat-strengthened glass, we heat it up over more than 600 degrees Celsius, and then we do a rapid cooling. So we use air, blow it on the surface to get the pre-stress into the glass, and therefore have an internal stress state, like we can see here for heat-strengthened and even higher for fully tempered glass. And during the cooling, we have all over the surface of the glass altering stress fields. So not everywhere it's fully uniform in the different axes of the glass. And therefore the glass becomes anisotropic. Depending on the lighting and installation situation, the anisotropies become visible. Here just a few of them. So the different scenarios are favoring the visibility of anisotropies. The main factor is the presence and high proportion of polarized light. This can be in the atmosphere, and then you have two main perspectives where we see these anisotropies strongly visible by the naked eye. So either at the angle of polarization, which is around 56 degrees, and there you see the stress differences really with the naked eye, or when we have a look perpendicular using polarized filters or polarized sunglasses. Anisotropy inline scanners are nowadays really common, and they allow for the quantification of these anisotropies in glass. So they determine the optical retardation all over the surface of the glass and do a continuous measurement. So they can do it even for glass in 20-meter lengths. The two different measurements are then combined to give a precise quantification all over the surface. So we have a reproducible result for each glass panel. And here we see red zones, and these highlight increased optical retardation and therefore visible anisotropies. How we can assess now the glass? According to the DIN spec, there is a cumulative distribution function formed all over the surface points, and then you get you have to take the 95% quantile and you receive a comparable value for each glass. And then with this value, the glass can be categorized in three different quality classes, so A, B, and C. And most likely the customers ask for quality class A, so the best product, of course, and they want to see the scan of the glass afterwards as a report. I think we all agree that these visible anisotropies that are still can be seen in quality A class is not what we as a glass processor want. And therefore, we say at Sedak, we try to improve the tempering process. So over years, we gave full power into this improvement to avoid anisotropies, and we invented a new technology, a tempering technology that allows for the for the tempering of the glass without visible anisotropies. And therefore, when we compare it now to a conventional quality A class, like seen here, where we have the red stress zones that will be visible later on in the glass when looking at certain angles. So this is the current state of the art for quality A class. And now it's Sedak Tempered Plus, so we don't have these red stress zones anymore. So all over the center, we don't have any red zones, and therefore we don't see any anisotropies with the naked eye for the glass. So based on this, we can give a new specification for the glass, which outperforms later on the A, B, and C quality classes. So when we compare now our tempered plus to the quality classes defined in the DIN spec for the glass, we have an outperforming of the current values, and therefore we can give our customers better glass without anisotropies. So nowadays, undisturbed glass facades become reality. I think it's not comparable to the first man landing on the moon, but we at Sedak say it's a small step for architecture, one giant leap for glass. You can also flip it. So Tempered Plus turns away the architect's nightmares. That's our aim with the new glass. And I would kindly invite you to have a look at our mock-up just around here, where you can see the comparison between a conventional tempered glass and a new Tempered Plus without visible anisotropies. I'm looking forward to discuss with you the thoughts on it later on at our Glass Technology Live tour. And thank you for your attention. And I think it was a very short time with this Pecha Kucha, but I hope I could catch you up. And I'm happy to answer some of your questions.